Now we are going to start with the properties of the first group, that is the alkali group. So the first property we will be taking into the consideration will be electronic configuration, because whenever we start with the properties, all the properties just revolve around the electronic configuration. So this is the basic property. See, so we have this thing lithium. You know that lithium's atomic number is 3. So if we just fill the electrons in the orbitals according to the increasing energies, we get 1s2, 2s1, or we can just compact it and write helium 2, 2s1. For sodium 11, it is neon 10, 3s1. For potassium, it's 19, so it is argon 18, 4s1. For rubidium, it is 37, so it is krypton 36, 5s1. Cesium is 55, so the configuration becomes xenon 54, 6s1. Francium is 87, so it is radon 88, 7s1. So see, whenever you are writing electronic configuration, you can write by showing the orbitals, but just filling them according to the increasing energies, or you can just you can just compact these orbitals into an electronic configuration. In terms of noble gas followed by the orbital. So it's like you can write in this way also and that way also. Both ways are correct. So now, as we know that we are familiar with the electronic configuration. So if we look for the similarity, like why these elements are grouped into one family. So as you can see, you can easily make out that in all of them, the last electron enters the s orbital. So this is the reason that they are s block elements. And as you can see that all the s orbitals possess one electron in their valence shell. See, it also possesses 2s1, 3s1, 4s1, 5s1. All of them has only one electron. So that is the reason they are like their last orbital is s orbital, and even the valence electron in the s orbital is same, that is 1. So that is why they belong to the one family. They are grouped into place them in one group, and they are a member of first group, that is the alkali metal group. Now moving on to the second property, that is the atomic size, that is the atomic radii and the ionic radii. So what we have seen actually, like when we talk of the atomic radii, we know that it is the first member of the second period, it is the first member of the third period, it is the first member of the fourth period. So if we talk of the period, as they are placed on the left side and the period is just starting from the left and ending on right, so these members are actually the first members of each period, and they are largest of all. Their size is largest of all. So that means among their series in the period, they are going to be largest of all, right? And why they are largest? Because they possess very less nuclear charge. Now we'll consider group now. So when we consider group, what we see that the size actually increase. The size actually increase. This you can easily make out. Just see here, lithium is 3, right? Lithium is 3. So that means configuration is 1s2, 2s1. For this thing sodium, it is 1s2, 2s2, 2p6, 3s1. For potassium, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So as what kind of changes do you see when you move in the group? We see that it has only two, like its outer shell is the second principal shell, and its outer shell is the third principal shell, and its outer shell is the fourth principal shell. So that means, like if this is my nucleus, so this is my first shell and this is my second shell. So lithium possesses these two shells. And if I talk about sodium, then this is my nucleus, this is my first shell, it possesses the second shell also, and it possesses the third shell also. As you can see that when we are moving down, every time a new shell is being added. As we see that here it is ending up at 2, here it ends up at 3, here it ends up at 4, and likewise we will see that fifth shell, sixth principal shell, seventh principal shell. So that means when we are moving down the group, every time a new shell is being added. Every time a new shell is being added, and due to this thing addition of the new shell, so that means the inner shell is being, because whenever the inner shell is being filled, then only the outer shell comes, right? So that means there are more electrons in the inner shell, and as we know that when the electrons in the inner shell increase, so then the screening effect also increase. So again, see, when we are moving down the group, every time a new shell is being added, and when the new shell is being added, so that means the inner shell is having more electrons and the shielding effect is somehow increasing. So that means, but we also know that whenever the shell get added up, or whenever the electrons get added up, equal number of protons also add. So that means with increase in shielding effect, obviously the nuclear charge will also be increasing. But what happens that when we move down the group, as we know that the shell is increasing, the inner shell electrons are increasing and the protons are increasing. So that means our shielding effect is also increasing and the nuclear charge is also increasing. What shielding effect is up to? It will just expand the size, right? And what is the fate of the nuclear charge? It is going to attract the electrons. That means it is going to shrink the atom. Now what is going to happen here? Actually, out of the shielding effect and the nuclear charge, like increase in the shielding effect and increase in the nuclear charge, the effect which is more pronounced will be the effect on the size, right? So out of them, the shielding effect and the nuclear charge, the shielding effect has the pronounced effect. That means it just overtake on the nuclear charge, and that is why when we move down the group, size is constantly increasing, right? So if somebody is going to ask you about the atomic size, you are going to just define it, that it is the distance from the center of nucleus to the outermost shell, and then just write the electronic configuration and just write that along group it increases. Then write the reason for it. Then write that when we are moving down the group, every time a new shell is being added, due to which there is an addition of electrons, there is addition of protons. Due to addition of electrons, the screening effect is increasing, and due to addition of proton, nuclear charge is increasing. But the pronounced effect of shielding effect caused this expansion of the electron cloud, the outermost shell, and that is why there is increase in the size. So that is the reason that atomic radii actually increase when we move down the group. So if somebody asks you about period, you should be quick with your answer that they are biggest of all in their period. And if somebody asks you about group, you should know that when we are moving down, the first member is going to be the smallest, lithium is going to be smallest, and the last member is going to be biggest in size, because every time a new shell is adding, the screening effect comes into play, and that is why there is an expansion of electron cloud. Now, in a similar way, you can answer the ionic radii. As you know that whenever atom lose or gain electron, it forms an ion. And as we know that they have actually a tendency to lose electrons, because they have one electron. After losing one electron, they will form a noble gas core. So that means they have a tendency to lose electron. And after losing, what kind of ion they form? Obviously they form cation. So if we talk about the size of cation, it varies in a similar way like the atomic radii vary. So if we talk of the atomic radii, lithium is the smallest, and the last member is the biggest. We do not take this francium into consideration because it is a radioactive element. So we'll talk regarding the properties only till the cesium, because we know that radioactive elements show anomalous properties. So we won't take those elements into consideration. So if we talk about the ionic radii, so obviously lithium is going to possess the smallest ionic radii, and as we move down, the ionic radii keeps on increasing. The reason being same, because when you have bigger size of atom, so obviously the cation which will be formed as a result will be smaller but still bigger as compared to the other members, right? So that is the atomic radii and the ionic radii, that how it varies when we move along group or when we move along period, right? Now the second property which we will be taking into consideration will be ionization energy. As you know that, suppose this is my nucleus, this is my outer shell, let's say I am drawing it for lithium, so which has 2 electrons in one s and 1 electron in the outermost shell. So now if I want to remove this 1 electron, obviously I need to supply it energy from outside. And that energy is particularly called as ionization energy. That is amount of energy required to remove most loosely bound electron from valence shell of an atom when it is present in a gaseous state. You are aware of the definition, we already did in periodic classification. So if we talk about the ionization energy, we know that it strictly depends upon the size, and the size strictly depend upon the nuclear charge. These are the factors that how they are interrelated. So if we talk of the period now, like in the period, we know that they are first member of their periods and they are biggest of all. They are actually biggest of all. So when that means their size is too large. Size too large corresponds that the nuclear charge is minimum. Like if we talk about period, the first member is going to possess the maximum size. Maximum size means the nuclear charge is minimum. Nuclear charge is minimum means that ionization energy which is required to remove the electron will be low. So this will be low only in case of period. Like if I am talking about the second period, then out of that second period, lithium, magnesium, I will write here. See, if I take into consideration lithium, magnesium, aluminium, silicon, this is what you have in a second period. So like every time I am just moving, when I am moving it, the size is decreasing. Along the period, size is decreasing because they are biggest of all. Biggest means they have maximum nuclear, lowest nuclear charge. So that is why they will be strongly pulled by the nucleus and ionization energy required will be very high. But now if we talk of group, so as we have seen that when we are moving down, the size is constantly increasing. Size is constantly increasing, that means we know that shielding effect is increasing. This is the reason we already discussed here, and due to which the nuclear charge is somehow decreasing. So when there is decrease in nuclear charge, that means the nucleus is not able to attract its outermost electrons with a greater force, right? So that means they are experiencing less pull from the nucleus, and due to the reason we can say that their ionization energy is decreasing. So whenever you move down the group, ionization energy is decreasing because it is merely based on the nuclear charge, and or you can say size, and size is merely based on the nuclear charge and the screening effect. So as we are moving down, we know that every time a new shell is being added, addition of new shell means screening effect is increasing, nuclear charge is decreasing. So that means the outer shell electrons are experiencing less pull. Less pull means less ionization energy will be required. So if I talk of the members from lithium to cesium, lithium is going to possess the highest ionization energy and cesium is going to possess the lowest ionization energy. Now this is the talk about the first ionization energy. Suppose I have lithium, its configuration you know is 1s2, 2s1. Suppose I have removed one electron, so after removal it has now become 1s2. So if I need to remove one more electron, you are right, I am talking about the second ionization energy. So if I need to remove the second electron, is it possible, or this second ionization energy is going to be higher or lesser? Obviously it is going to be high. So that means second ionization energy is greater than the first one. The reason being because here it was a noble core and there was a loosely bound electron. But after the removal of electron from the 2s, it has now acquired a noble core. That means it is now more stable, and we know that we cannot disturb noble gas configuration, and if we wish to do that, we require a large amount of energy. So obviously ionization energy 2 will be greater than ionization energy 1 for the alkali group metals. Now coming on to the next property, that is the metallic character. We classify the elements into metallic, into non-metallic, right? So what is metallic character actually? Metallic character is tendency to lose electrons. Tendency to lose electrons. So as you all know that they have one electron in s orbital, and after losing they will acquire a noble gas configuration. So that means they are in immediate need of the removal of one electron because they need to attain stability, right? So that means they will not accept an electron, and like instead of accepting, they are more keen of donating an electron. And why is it so? Because they possess the low ionization energy. So if we talk of period, we know that in period they are biggest of all. Biggest means they possess the low ionization energy, and that means they can easily lose electron. So that means they are most metallic in their period. So when we talk of second series, second period or third period, they are actually most metallic. Lithium is most metallic of the all members of the period, and sodium is most metallic in the third period, likewise. But if we talk of the group, so we know that as we are moving down, size is increasing, ionization energy is decreasing. We have already discussed the factors, right? So ionization energy is decreasing. So obviously metallic character is increasing. So that means the electron which is present in the bottom of the first group is able to lose electron more easily within more ease as compared to the electron which is present here, like if you wish to remove an electron from the first one. So because we know that it is smallest of all, so that means it is going to possess the highest ionization energy. Highest ionization energy means it is less metallic. But as we move down, size is increasing. Size is increasing means the ionization energy is decreasing, so that means metallic character is easily, because it can easily lose an electron. So this is how you are going to talk of the metallic character. So that means extreme left is the metals, and as we move down, the tendency to lose electron is decreasing. We will be discussing in the P block that. So the metallic character is extreme on the left side. Now if we talk of oxidation state, so as I have told you that like they have 1s2, 2s1, or they have this thing 1s2, 2s2, 2p6, 3s1, that means all of them are having one electron in the outermost shell. So after removal, like I will write for lithium, suppose it is 1s2, 2s1, and when it will lose one electron, it will form 1s2. So what the oxidation state you think that it will show more common? Obviously it will show one of this thing +1 oxidation state. The reason being that for the removal of one electron, the ionization energy needed is very low. But after the removal of one electron, it is acquiring a noble gas core. Noble gas core, what does it mean? That means it is acquiring a stable configuration. Stable configuration means the ionization energy too will be very high. So they won't show in a common manner. So their common oxidation state is +1. Right. Likewise, we have the one more property, nature of bond form. As you have seen that they are metallic because they have less ionization energy. That means they can easily lose electron. They can easily lose electron. That means they have tendency to form ionic bond, because ionic bond is formed by the transfer of electrons, one atom lose and the other gain. So that means they have more tendency to form the ionic bond as compared to the the p block elements. So if we consider this series, so obviously this whole series is going to show +1 oxidation state, and if we talk about the nature of bond, it just depends upon the ionization energy. So as we know that along the group, as we are moving, size is increasing, ionization energy is decreasing, that means metallic character is increasing, that means tendency to form ionic bond is increasing. So out of lithium and cesium, cesium will have more tendency to form an ionic bond as compared to the lithium because of its small size and high ionization energy. So this is what I took some few properties. We will be discussing more now, but for this time I think you got it in a right way, that what is atomic radii, ionic radii, how it varies, what is the ionization energy, which element is going to possess highest ionization energy in period, or which is going to possess the highest or lowest in the group. And if we talk about, we compare about first ionization energy and the second ionization energy of the alkali metal, I think you can answer now. And oxidation state, obviously because they get the second ionization energy is too high, so obviously they show an oxidation state of +1, as they have tendency to lose electron because they are biggest in the period, in their period actually. So that means they are most metallic, and as we move down, size increasing, ionization energy decreasing, so that means metallic character is obviously increasing. Likewise, they have tendency to lose electrons, and an element which has tendency to lose electrons is more capable of forming the ionic bond, right. So these are the few properties. Now we will be taking the rest one.